2. Determination of money prices. Let us first take a typical good and analyze the determinants of its money price on the market. Here, the listener is referred back to the more detailed analysis of price in Chapter 2. Let us take a homogeneous good, grade A butter, in exchange against money. The money price is determined by actions decided according to individual value scales. For example, a typical buyer's value scale may be ranked as follows. At the top, 7 grains of gold, followed by a first pound of butter, followed by 6 grains of gold, followed by 5 grains of gold, followed by a second pound of butter, followed by 4 grains of gold, followed by 3 grains of gold, followed by a third pound of butter, followed by 2 grains of gold. The quantities of butter are those which the person does not possess, but is considering adding to his ownership. The others are those which he has in his possession. In this case, the buyer's maximum buying money price for his first pound of butter is 6 grains of gold. At any market price of 6 grains or under, he will exchange these grains for the butter. At a market price of 7 grains or over, he will not make the purchase. His maximum buying price for a second pound of butter will be considerably lower. This result is always true and stems from the law of utility. As he adds pounds of butter to his ownership, the marginal utility of each pound declines. On the other hand, as he dispenses with grains of gold, the marginal utility to him of each remaining grain increases. Both these forces impel the maximum buying price of an additional unit to decline with an increase in the quantity purchased. Now suppose that the man had already paid 6 gold grains for 1 ounce of butter. When he decides on a purchase of another pound of butter, his ranking for all the units of money rise, since he now has a lower stock of money than he had before. Our tabulations, therefore, do not fully portray the rise in the marginal utility of money as money is spent. However, the correction reinforces rather than modifies our conclusion that the maximum demand price falls as quantity increases. From this value scale, we can compile this buyer's demand schedule, the amount of each good that he will consume at each hypothetical money price on the market. The individual demand schedule of the buyer under consideration is as follows. At a market price of 8 grains of gold per pound of butter, this buyer demands 0 pounds. At a market price of 7 grains of gold per pound of butter, this buyer demands 0 pounds. At a market price of 6 grains of gold per pound of butter, this buyer demands 1 pound. At a market price of 5 grains of gold per pound of butter, this buyer demands 1 pound. At a market price of 4 grains of gold per pound of butter, this buyer demands 2 pounds. At a market price of 3 grains of gold per pound of butter, this buyer demands 2 pounds. At a market price of 2 grains of gold per pound of butter, this buyer demands 3 pounds. At a market price of 1 grain of gold per pound of butter, this buyer demands 3 pounds. We note that because of the law of utility, the quantity demanded as the money price falls must be either the same or greater. If this is the necessary configuration of every buyer's demand schedule, it is clear that the existence of more than one buyer will tend greatly to reinforce this behavior. There are 2 and only 2 possible classifications of different people's value scales. Either they are all identical, or else they differ. In the extremely unlikely case that everyone's relevant value scales are identical with everyone else's, extremely unlikely because of the immense variety of valuations by human beings, Then, for example, buyers B, C, D, etc. will have the same value scale, and therefore the same individual demand schedules as buyer A, who has just been described. To be sure, the value scales of the buyers will almost always differ, which means that their maximum buying prices for any given pound of butter will differ. The result is that as the market price is lowered, more and more buyers of different units are brought into the market. As an example of the formation of a market demand schedule from individual value scales, let us take the buyer described earlier as buyer A and assume two other buyers on the market, B and C, with the following value scales. Buyer B's value scale is topped by 6 grains of gold, followed by the first pound of butter, followed by 5 grains of gold, followed by a second pound of butter, followed by 4 grains of gold, followed by 3 grains of gold, followed by 2 grains of gold, followed by a third and fourth pound of butter, followed by 1 grain of gold. For buyer C, his value scale is topped by 5 grains of gold, followed by 4 grains of gold, followed by a first pound of butter, followed by 3 grains of gold, followed by a second pound of butter, followed by a third pound of butter, followed by 2 grains of gold, followed by a fourth and fifth pound of butter, followed by 1 grain of gold. From these value scales, we can construct their individual demand schedules. For buyer B, at a price of 7 grains per pound, the quantity demanded of the butter is 0 pounds. At a price of 6 grains per pound, 0 pounds are demanded. At a price of 5 grains per pound, 1 pound is demanded. At a price of 4 grains per pound, 2 pounds are demanded. At a price of 3 grains per pound, 2 pounds are demanded. At a price of 2 grains per pound, 2 pounds are demanded. At a price of 1 grain per pound, 4 pounds are demanded. For buyer C, at a price of 5 grains per pound, 0 pounds are demanded. At a price of 4 grains per pound, 0 pounds are demanded. At a price of 3 grains per pound, 1 pound is demanded. At a price of 2 grains per pound, 3 pounds are demanded. And at a price of 1 grain per pound, 5 pounds are demanded. Now we may summarize the individual demand schedules, A, B, and C, into the market demand schedule. The market demand schedule yields the total quantity of the good that will be bought by all the buyers on the market at any given money price for the good. The market demand schedule for buyers A, B, and C is as follows. At a price of 7 grains per pound, 0 pounds are demanded. At a price of 6 grains per pound, 1 pound is demanded. At a price of 5 grains per pound, 2 pounds are demanded. At a price of 4 grains per pound, 4 pounds are demanded. At a price of 3 grains per pound, 5 pounds are demanded. At a price of 2 grains per pound, 8 pounds are demanded. And at a price of 1 grain per pound, 12 pounds are demanded. The principles of the formation of the market supply schedule are similar, although the causal forces behind the value scales will differ. Each supplier ranks each unit to be sold and the amount of money to be obtained in exchange on his value scale. Thus, one seller's value scale might be as follows. Seller X, at the top of his value scale, 7 grains of gold, followed by 6 grains of gold, followed by a 1/6 pound of butter, followed by 5 grains of gold, followed by a 1/5 pound of butter, followed by a 1/4 pound of butter, followed by 4 grains of gold, followed by a 1/3 pound of butter, followed by 3 grains of gold, followed by a second pound of butter, followed by a first pound of butter, followed by 2 grains of gold, followed by 1 grain of gold. If the market price were 2 grains of gold, this seller would sell no butter, since even the first pound in his stock ranks above the acquisition of 2 grains on his value scale. At a price of 3 grains, he would sell 2 pounds, each of which ranks below 3 grains on his value scale. At a price of 4 grains, he would sell 3 pounds, etc. It is evident that, as the hypothetical price is lowered, the lower price must lead either to a lesser or to the same supply, never to more. Again, the reason is the law of utility. As the seller disposes of his stock, its marginal utility to him tends to rise, while the marginal utility of the money acquired tends to fall. Of course, if the marginal utility of the stock to the supplier is nil, and if the marginal utility of money to him falls only slowly as he acquires it, the law may not change his quantity supplied during the range of action on the market. Thus, a supplier Y might have the following value scale. For seller Y, his value scale is topped by 6 grains of gold, followed by 5 grains of gold, followed by 4 grains, followed by 3 grains, followed by 2 grains, followed by a 6th pound of butter, followed by a 5th pound of butter, followed by a 4th pound of butter, followed by a 3rd pound of butter, followed by a 2nd pound of butter, followed by a 1st pound of butter, followed by 1 grain of gold. This seller will be willing to sell above the minimum price of 1 grain every unit in his stock. In seller X's case, his minimum selling price was 3 grains for the 1st and 2nd pounds of butter, 4 grains for the 3rd pound, 5 grains for the 4th and 5th pounds, and 6 grains for the 6th pound. Seller Y's minimum selling price for the 1st pound and for every subsequent pound was 1 grain. In no case, however, can a lower price lead to more units supplied. Let us assume, for purposes of exposition, that the suppliers of butter on the market consist of just these two, X and Y, with the foregoing value scales. Then their individual and aggregate market supply schedules will be as follows. At a price of 8 grains per pound, X will supply 6 pounds, Y will supply 6 pounds, and the market will supply 12 pounds. At a price of 7 grains per pound, X and Y will both supply 6 pounds, and the market will supply 12 pounds. At a price of 6 grains per pound, X and Y will both supply 6 pounds, and the market will supply 12. At a price of 5 grains per pound, X will supply 5 pounds, Y will supply 6 pounds, and the market will supply 11. At a price of 4 grains per pound, X will supply 3 pounds, Y will supply 6 pounds, and the market will supply 9 pounds. At a price of 3 grains per pound, X will supply 2 pounds, Y will supply 6 pounds, and the market will supply 8 pounds. At a price of 2 grains per pound, X will supply no pounds, Y will supply 6, and the market will supply 6. And at a price of 1 grain per pound, no pounds will be supplied by X, Y, or the market. We notice that the price at which the quantity supplied and the quantity demanded are equal is here located at a point in between two prices. This is necessarily due to the lack of divisibility of the units. If a unit grain, for example, is indivisible, there is no way of introducing an intermediate price, and the market equilibrium price will be at either 2 or 3 grains. This will be the best approximation that can be made to a price at which the market will be precisely cleared. That is, one at which the would-be suppliers and the demanders at that price are satisfied. Let us, however, assume that the monetary unit can be further divided, and therefore that the equilibrium price is, say, 2.5 grains. Not only will this simplify the exposition of price formation, it is also a realistic assumption, since one of the important characteristics of the money commodity is precisely its divisibility into minute units, which can be exchanged on the market. The money price on the market will tend to be set at the equilibrium price, in this case at 2.5 grains. At a higher price, the quantity offered in supply will be greater than the quantity demanded. As a result, part of the supply could not be sold, and the sellers will underbid the price in order to sell their stock. Since only one price can persist on the market, and the buyers always seek their best advantage, the result will be a general lowering of the price toward the equilibrium point. On the other hand, if the price is below 2.5 grains, there are would-be buyers at this price whose demands remain unsatisfied. These demanders bid up the price, and with sellers looking for the highest attainable price, the market price is raised toward the equilibrium point. Thus, the fact that men seek their greatest utility sets forces into motion that establish the money price at a certain equilibrium point, at which further exchanges tend to be made. The money price will remain at the equilibrium point for further exchanges of the good until demand or supply schedules change. Changes in demand or supply conditions establish a new equilibrium price, toward which the market price again tends to move. What the equilibrium price will be depends upon the configuration of the supply and demand schedules, and the causes of these schedules will be subjected to further examination later. The stock of any good is the total quantity of that good in existence. Some will be supplied in exchange, and the remainder will be reserved. At any hypothetical price, it will be recalled, adding the demand to buy and the reserved demand of the supplier gives the total demand to hold on the part of both groups. The total demand to hold includes the demand in exchange by present non-owners and the reservation demand to hold by the present owners. The seller's reservation demand will fall with a rise in price or will be non-existent. In either case, the total demand to hold rises as the price falls. Where there is a rise in reservation demand, the increase in the total demand to hold is greater. If there is no reservation demand schedule on the part of the sellers, then the total demand to hold is identical with the regular demand schedule. Thus, the higher the market price of a stock, the less the willingness on the market to hold and own it, and the greater the eagerness to sell it. Conversely, the lower the price of a good on the market, the greater the willingness to own it, and the less the willingness to sell it. Since all units of an existing stock must be possessed by someone, the market price of any good tends to be such that the aggregate demand to keep the stock will equal the stock itself. Then the stock will be in the hands of the most eager or most capable possessors. These are the ones who are willing to demand the most for the stock. That owner who would just sell his stock if the price rose slightly is the marginal possessor. That non-owner who would buy if the price fell slightly is the marginal non-possessor.